So we're going to extend our knowledge of whole number exponents and start working with rational exponents. So remember that the word rational just means fraction. So this whole section, we're going to have exponents that are fractions. Now, all of my same rules apply in terms of the power to power, quotient of a power, all of those things you learned in Math 101, those rules still apply to your rational exponents. The thing that you may have to do first, though, is convert from radicals, things that look like this, to rational exponents. And the way you're going to do that is through this property right here. So this property says that if you have the root, some kind of root of x to a power, so the square root, the cubed root for us, that you can convert it by the exponent inside going on top and the exponent outside going on the bottom. So this is the property as to how you can convert back and forth between radicals to exponents. And once we convert it to exponents, then all of my exponential rules apply because it's now an exponent. So the first example is 81 x to the fourth all to the 1/2 power. So this is the product to a power problem because I have several things inside the parentheses all to the 1/2. So what I'm going to do is distribute the 1/2 to each thing. So 81 to the 1/2 power and x to the fourth to the 1/2 power. Now 81 to the 1/2, that I can put in my calculator because it's a number, but that just means if I use that property again, kind of thinking aside, 81 to the 1/2 is the same thing as the base stays the same. 1 is going to stay inside. 2 is going to go outside. So 81 to the 1/2 is the same thing as the square root of 81, which is 9. Now over here with this x to the fourth to the 1/2, that is now power to a power. So if two powers being so to solve that, I'm going to multiply 4 times 1/2. So you can either do that in your calculator or do that off to the side. So you're going to get x squared. So your final answer would be 9x squared. Okay, the next one, I'm starting in radicals, so the first thing I have to do is convert. So I have to go from radicals to convert to exponents because I don't have any properties regarding radicals other than I can stick them together. So I want to convert both of these to exponents. Now, if I don't have an index written, if you remember from 8.1 or 9.1 that it's an implied 2, so I'm going to have x, the inside squared, this squared, divided by the index, so I have x to the 2 over 2, and then this one I'm going to have times x to the 5th, because it's inside, over the index. Now I have two big bases being multiplied, so that Pima that I referenced in class and on the last video says that if you have two big bases being multiplied, that you're going to add them. So I'm adding them in the exponent. They already have like bases, so I can go ahead and combine them and leave it as x to the 7 over 2. Or you could convert it back to a radical, which would say x to the 7th square root, but I do not need to write the squared, so it would, or I don't need to write the 2, so it would be the square root of x to the 7th. I would accept either one of those answers. Okay, the third one, I've got a string of exponents. So this is just a whole bunch of power or product rules because I've got a whole thing's being multiplied. And again, Pima says that if you've got things being multiplied, that you're going to add the exponents. Well, I'm only adding the exponents of the like bases. So I'm going to add x to the 4, x to the negative 4, x to the third, and x to the negative 2, because all of those are like bases. So I'll have negative 4 plus 3 plus negative 2 over 3. Now, what do I do with those numbers out front? Well, that's the same thing as I just multiply all the numbers out front. So the numbers, I have 7, 4, and a 1 there. So out front, I'm going to get 28. Now, that thing in the top, I can just type all that in my calculator or do it in your head, however you want to do it. The thing is, if you type it into your calculator and you get a decimal, make sure you convert it back to a fraction, because I want fraction exponents. I don't want decimals. So I'm going to have 28x to the negative 5 over 3. Now in Hawks, it is going to say to write it only using positive exponents. So right now, I have negative 5 over 3. I want to convert that. Well, I have a property that says that you can cross the line, change the sign, meaning I'm going to take that thing down to the bottom, have it x, change the sign, positive 5 over 3, and the 28 stays on top. The reason the 28 doesn't go to the bottom is because it doesn't have a negative exponent. So anything that doesn't have a negative exponent stays where it is. Only the base and the exponent move down or move up for the positive, negative stuff. Okay, the next one, I got a whole bunch of stuff all raised to the 1/2 power. Well, I have a property that says you can distribute, we use that term loosely, you can distribute and give every single piece its own exponent. So 25 gets a 1/2, x gets a 1/2, y gets a 1/2, y gets a 1/2, x gets a 1/2. So let's rewrite that. I've got 25 x y negative 2 x cubed y negative 2. So I've gone through and I distributed the 1/2 to everything inside. So every single thing gets a 1/2. Now I go through and simplify. So 25 to the 1/2, we saw in the other example that 25 to the 1/2 power is the same thing as the square root of 25, which gives me 5. X to the 1/2 doesn't change, but y to the negative 2 1/2, that is my PIMA that says power to a power you multiply. So I'm going to take negative 2 and multiply times 1/2. And I get out negative 1. So I'll have y to the negative 1 power over, I'm going to do the same thing on the bottom, x cubed to the 1/2, multiply, so I'll have 3 times 1/2, which will give me x to the 3/2. Same thing with y to the negative 2, then to the 1/2, that's power to a power, so I multiply, so I have negative 2 times 1/2, so I'll have y to the negative 1 again. Okay, so now I'm working on simplifying like bases. So 5, there's no other number, so that 5 is just going to stay along. The x's, though, those x's are now being divided. So when like bases are being divided, I'm going to subtract top 1/2 minus the bottom. So top 1/2 minus 3 over 2 is going to give me x to the negative 2 over 2. Again, you subtract top minus bottom, and it stays on top. And then the y's, if I were to subtract that, I'm going to have subtract top minus bottom. So I have -1 minus -1. That's going to turn negative, negative turns to plus. So those actually are going to give me y to the 0, which means those two are going to cancel out. And the reason they cancel out is because everything's being multiplied and they're the same exact thing. Anytime you have the same thing on the top as the same thing on the bottom, they're going to cancel. So I'm just left with 5 to the negative 2 over 2, but I can simplify that to be 5x to the negative 1. Now, I can't leave negative exponents, so I'm going to take this whole thing, cross the line, change the sign. So I'm going to take it from the top, move it to the bottom. So I have 5 over x to the positive 1, which is just 5 over x. So your final answer is 5 over x.